All right. Good afternoon here. Um, just want to go over a little project. I've been wanting to do a 8x8 matrix scrolling display, and this happened to be going through Amazon, and there was this Chinese um, 4 segment 8x8 display for the Arduino. And I thought it would be interesting to get it working for my computer. Initially, I wrote a routine just to test out um, the bit banging, the SPI type output on my Z80 PIO. It was a bit slow, so the next step would optimize it by doing it in assembly. And just a quick overview of what we got here. The display has 4 boards, and you can actually cascade them together. It uses the Max 7219 7 segment 8 display driver. And what they're doing is the Max can be programmed either to decode 7 segment displays or this 8 individual LEDs, being that your decimal point is the 8th digit or display. So that's how we are able to run an 8x8 display, because it's 8 displays, and when you count the 7 segments plus the decimal point, you get 8 positions. So after initially writing this little simple C program to test out right to the port, it worked, but it was very slow. So I went optimized with assembly. And just as a look at this, I'm going to go over to my board real quick. I have on the bottom board is the Z80 at 4 megahertz, 2 8K RAM chips, a CTC, and a Z80 PIO. Above is my expansion board with my breakout ports, 2 more 8K RAMs, the Z80 SIO, and we have the Pi Zero, in which I use its I2C interface to drive 3 8-bit bus drivers. It has each chip has 2 8-bit ports, in which I'm able to call the Z80 bus request line, and then once the Z80 acknowledges the bus request, I hijack the bus and then write my program into the RAM. I also could write to an EEPROM when I want to make it more permanent. But for development, I find this very easy just to write directly to it. And I can do things like from the Pi, reset the program. I can monitor it. Unfortunately, because I'm driving the clock line directly, this was the optimum way to get the buses using the bus request line to just have the Z80 give up the bus. Now, the Pi, I'm using it in a USB, they call it USB gadget mode, in which I can shell in it using SSH and actually have a little program compiled on the Pi that takes a binary file that I've created on my Linux system using Z88DK to drive the I2C bus drivers and then write the program. I use a simple program called Kate text editor. It automatically knows the format for either C programs or assembly. It's a nice little program. I like how it works. I have 2 shells, 1 shell into the Pi and 1 shelled into the folder of the program I am compiling. I will come here real quick. There's a couple of warnings here, and those are like, I have an infinite loop, and it crops at me about that. And there's a couple places where I've changed code and just left variables uninitialized, and it grumps about that. But other than that, it works good. Then I have the shell into my Pi. Let me click on the window this time, and I'm going to hit the little custom program I wrote, and it's also written in C, and it runs a lot faster on the Pi. It opens the ITC bus, initialize the ports, reset ports, and this gives me things that was waiting for the Z80 to race the bus. And when it acknowledges, it starts loading RAM. And we come down here, and then in just a few seconds, a little more, I make it change the frequency on the ITC bus. We should have the new assembly program running the data into the display. Note, I'm actually writing it upside down in the program to shift it out from this angle. This happened to be the way I decided to run it. But here you go. This is about a medium speed. I can slow the delay and it'll really zip across. But of course you cannot see the data being loaded into the chips. So it's pretty good, smooth loading and scrolling. Later, maybe find some application with it and do more. But like I said, I saw this on Amazon. I thought it'd be neat to try out and then have it ready for some future application. I'm going to have a link below to the code on how to use the assembly. I mean, it could be any type of PIO device or just a simple 8-bit register output device to drive this. You just need to change the addressing in the code, in assembly code to wherever your device is. And if it needs any kind of setup codes, this one in my code sets up the Z80 output port to an output. All right, well, I hope you enjoy this, and maybe if you have some questions or suggestions when you look at the code, feel free to tell me. All right, bye.